Welcome to this video that is going to go through solving systems of equations that are linear. We will take and quickly review the processes we would have encountered in grade 10 math for solving linear systems, which involve two equations with two unknowns, and then we will progress and show you how you could use that to solve systems that involve three equations with three unknowns. Okay, so let's get a look at what we would have covered last year. So last year we would have in your NRF course, we would have studied how to solve a system of equations. This would be an example of a system of equations down here. So it's two equations that involve two unknowns. We would have done them by graphing first. At this level, if we're going to solve them by graphing at the pre-calculus level, we're going to actually use technology. So I'm just going to jot my two equations down here, just 1 second. All right, so I've got my equations written down here because I'm going to leave my smart notebook here. I'm just going to go to Desmos. So this would be the app that you would have on your phone, most of you. And we are going to go to the graphing calculator. This is the web-based version, which looks very similar. And the beauty of Desmos is, unlike a graphing calculator, you do not have to rearrange your equations to be y equals. So the two equations we had were 2x plus y is equal to 5. That was equation 1. Enter. And then the other equation was 3x. Take away 4y. Oops, what did I do here? 3x take away 4y is equal to 2. And then what you're looking for is an ordered pair that works in this line and an ordered pair that also works in this line at the same time. So by visualizing, the only way that could possibly happen, so example, if I pick a point here, it's only on the blue line. If I pick a point here, it's only on the red line. The solution to a system is an ordered pair that's on both lines at the same time. Well, that is only right there. So what you're looking for is where the lines intersect each other. So that would be the solution to this system of equations, 2, 1. X would be 2, y would be 1. So that's one way to solve a system of equations. Input your two lines and see where they cross. And again, we would probably do that pencil and paper. We would rely on technology to do that. All right, so back to our other methods of doing this. So we looked at graphing. Have that one done. Let's look at substitution. So substitution, as the name would suggest, is going to require us to substitute one variable from one equation into the other equation. Now you want to be strategic about this. So you want to look this over and identify, is there one of the variables in one of the equations that would perhaps be easier than the others to rearrange to get by itself. For example, this one here, by all means you could rearrange it, it would work, but whether you get x equals or y equals, you're going to end up dividing by 3 or by 4, which is going to generate fractions, and that will make the work a bit more difficult. This would be the best equation to pick, and the letter y would be the best one to isolate, because simply moving the 2x over here, you have isolated to get the y by itself. Now remember, the goal of this is to find an x and a y that work in both equations, meaning the y here, we want it to be the same as the y over here. So what we're going to do is take this y and replace it with what y equals, which is this expression. That's going to make this equation. So 3x minus 4, replace the letter y with what y is equal to, 5 minus 2x is equal to 2. So now I'm going to solve this. 3x subtract 20 plus 8x equals 2. So I kind of got excited and got going too quick here. The beauty of what we just did is it generated an equation that only had one unknown. And we've had lots of practice solving those types of equations, which is what I'm doing now. So I'm just going to collect all my x's on one side, numbers on the other side, x equals 2, which we know is the correct answer because we already had solved this by using the graphing strategy. Once you have your answer, you're going to put it back into here, would be the easiest way. I mean, in theory, you can put it in here if you want, but this would be the easiest one. So you always try and find the easiest substitution to substitute this back into here. So now it's going to be 5 minus 2. We now know that the x, we just got it here, x can be replaced with what it's equal to, which is the number 2. 5, this is 4, so 5 take away 4 is 1. So we're doing this algebraically using substitution. I would deem the answer to be 2, 1, which is what we got by doing it graphing. Okay, I'm going to solve this. So this would be using the substitution strategy. You need to be familiar with all of these and be able to put them all into play. Sometimes, as these get more complicated, you might do even a combination of both. Do some eliminating and then some substituting. So you need to understand how both processes will work. So I'm going to move on now and do the same system, and I'm going to use elimination. All right. Get my system down here. So elimination, what you want to do is rearrange the equations so they're in the same order. So what I mean by that is I've got x plus the y, and then it equals the number. So that's what I would want. I want the other equation to be laid out in the same pattern. X, the y, and the number. So 3x, take away 4y, is equal to, in this case, 2. So this is now our system. But I've got them lined up for what we call elimination. In order to use elimination, you want one of your variables, whether it's the x or the y, to end up with the same coefficient, number in front. Now I could do that in a variety of ways in this one. I could get the x's to both be 6's, for example. If I multiplied this whole equation by 3, that would make this 6x. And if I doubled everything in this equation, that would make this a 6. And then they'd be the same and I could eliminate them. And that would work fine. I think I would rather, in this case though, eliminate the y's. And the reason I would say that is because then I only have to multiply one of the equations. Now, if I backtrack, multiplying this one by 3 and this one by 2 is really not very difficult, so that would be a fine way to do it. However, just to show you that if you want to limit your amount of work, if you just multiply this equation by 4 or negative 4, either one would work. I'm just going to multiply by 4, and it would make the new equation 8x plus 4y equals 20. So you got to make sure you multiply everything by 4 so the equation's still true. Then, at this point, you look at the ones that have the same number in front, and you determine whether you're going to add the two equations together or you're going to subtract the two equations. Now, it's not a random choice. You have to pick the right one. If these are opposites, in order to eliminate them, you'd want to add the two. If these were the same sign, well, then you'd want to subtract the two. Based on what I see here, I would want to take these two equations and add them together. 3x plus 8x, 11x. A negative 4y plus a positive 4y, 0. There's where it gets the name elimination. I've eliminated the letter y. 2 plus 20, 22. Divide by 11, divide by 11. X, in this case then, would be equal to 2. Find the easiest equation that you can. I would suggest the top one. And now you're going to substitute this in for the x to solve for y. So 2 multiplied by the x plus y equals 5. That's going to now let me determine the value of y. So this is 4. I'm going to have to take away 4 from both sides. Y will end up equaling 1. X is 2, y is 1. So for the third time, we got the same answer. So this would be material that you've already seen before. Hopefully it's just a matter of, as I put at the top, just activating this prior knowledge that was in your brains, just a matter to dust it off and remember that it's actually in there. Okay, so let's try one more of those. So I suggest you probably at this case maybe want to pause and try this on your own. I'll just give you a heads up that it was a system that I had just randomly made up without taking the time to carefully determine whether the system would have nice integer solutions. This one will have fraction solutions, which is fine. The world isn't always perfect with integers all the time, but don't be alarmed if you get fractions for your answers. All right, so here's my solution. Any method you want, doesn't matter. I'm going to use substitution. I'm going to take this equation and rearrange to get the y by itself. So I'm going to get negative 3x plus 1 when I move that to the other side. I am then going to take this and substitute it in here instead of the letter y. So it'll now become 2x plus 4 equals 3 times y being this expression. And like before, now I just have a single variable. So 2x plus 4, oops, hit my eraser, is equal to negative 9x plus 3. That's when you distribute in here. Collect your x's on the other side or on one side. Move your numbers to the other side. Divide by 11. Divide by 11. If they don't go evenly, just leave it as a fraction. So there's what x would equal, negative 1 over 11. Take this answer, put it in here to get your y value. So my y value is negative 3 multiplied by my x value plus 1. So y will equal then positive 3 over 11 plus 1, which is the same thing as 11 over 11. That tells me my y value then must be 14 over 11. Correct answer, negative 1 over 11, 14 over 11. And again, you could have used, sorry, I should have clarified in the beginning, I did not want you to use Desmos and graphing. I wanted you to do it pencil and paper. All right, so we're going to, that's NERF 10. That's grade 10 skill set you should have brought with you to pre-calc. We're going to extend upon that ever so slightly, and we're going to move on to do systems of equations that are what we deem to be 3 by 3. 3 equations, 3 unknowns. 1, 2, 3 equations, A, B, and C, 3 different variables I'm trying to figure out. And we're going to use the same skill set we have. It basically requires you to do the work that you do for a 2 by 2 system twice. All right, well, one thing I noticed before I start this system is that the last equation only has 2 variables in it. So that can help you do things a bit quicker. And you have to take note of what variables are present in this equation. So in this equation, there are b's and c's. So if I could somehow generate a new equation from the top 2 that had just b's and c's in it, that would be a way to solve this system like I would have done in NERF 10. You got 2 options. You could rearrange this. This is probably the easiest one. So A would be, move these over here, and then substitute that in for A, tidy things up, you'd have an equation with b's and c's in it. Although, I think a quicker way, if you notice, this is set up very nicely for these a's to eliminate. Let's just take the 2 a's, or the 2 equations, negative a plus 3b, take away 6c equals 20. Line this one up underneath it, a plus 4b, take away c equals 15, and let's eliminate. So if I have a negative a and a plus a, to eliminate I'd want to add the 2. So negative a plus a, 0. Now you have to do the same operation all the way across. 3b plus 4b, 7b. A negative 6c plus a negative 7c, or sorry, a negative 1c is a negative 7c. 20 plus 15 is 35. Now at this point, depending on what this equation looked like, you got to kind of look around and don't just blindly, randomly do things because it's possible. For example, I could divide everything in this equation by 7 to simplify it. But that's probably not a great idea in this equation because if you look here, the b in this third equation down here already has a 7 in front of it, then that'll match up with this. So it's probably best to leave this just the way it is. Now you're going to take these 2 equations and match them up in a 2 by 2 pattern. So I've got two equations, 2 unknowns. Negative 7b take away 5c equals a negative 23. Line this up underneath it, 7b take away 7c equals 35. So the beauty of that is these already have the same coefficient. So to eliminate, I'm just going to add the 2 equations. Add these 2. Add these 2. And c equals negative 1. So there's a good start. Pick one of these equations involving b and c. So either this one or this one. I'll take the bottom one just because it doesn't have as many negatives in it. So I'm going to go 7b take away 7c. That would have to equal 35. 7b, now negative, this is a negative 7, so this is really plus 7, is equal to 35. So I'm going to have to subtract 7 from both sides. So 7b is 28. Divide both sides by 7. B has to equal 4. So I've got the c value, I've got the b value. Only thing now missing is the a value. Now you need to find the easiest possible equation you can pick out. And again, sometimes there's really no difference, but it has to have an a in it, because I'm trying to solve for a, and then be a combination of these variables. So how about we go with this one? A plus 4 times b, but I know the value of b now is 4, minus c, but I know the value of c is -1, and that has to equal 15. So that leaves me my one unknown, a. So a plus 16 plus 1 is equal to 15. This will be 17, so move it to the other side. I'm going to get a is equal to -2, giving me the solution, -2, 4, and -1. So one of the things with these, when there's no context in the question, now sometimes you might be told that b is on the x-axis and h is on the y-axis, or vice versa. If there's no context and you're just solving for random unknowns, when you identify them as an ordered pair, or in this case a triple, always put them in alphabetical order. Alphabetical order. So that would mean that this is the A, this is the B, and this is the C value. All right, I'm going to do one more of those. So here's my second one. I'm going to let you, perhaps if you want, give it a try on your own. So you could pause the video, write it down, try it, using a combination of eliminating and substitution, or all substitution, just using the skills you've acquired in NERF 10 to manage a 3x3 system. All right, so here's a look at my solution. When I looked at this, what I noticed right away were these 3's all lined up here, which is very nice for elimination. So I should be able to eliminate C in both of these equations pretty efficiently. So I'm going to take the top two first, -6a plus 2b, take away 3c is equal to 23. I'm going to line that up with this one, 5a plus 4b plus 3c is -12. And to eliminate the c's, because they're opposite signs, I'm going to add the equations all the way across. -a plus 6b equals 11. So there's a new equation, but the beauty of this equation is it only involves two variables because I've eliminated the c's. Now the key to this is when you pick two equations and you eliminate a variable, you're going to now pick two more equations, two different ones. Again, you can use one of these, but you can't use the same two. So one of these and the one we haven't used yet, and we're going to eliminate the same variable. So you can't eliminate c's in this one and then maybe over here say, oh, the b's would eliminate very nicely and get rid of those, because then your equations aren't going to have the same letters in them. In order to get another equation with a's and b's in it, I need to, regardless of whether it's easy or not, I have to eliminate the c's. Now this one was set up very nicely, and I picked c on purpose because I saw that these also had the same coefficient. So I'm going to now take the middle equation. You could also use the top and the bottom, doesn't matter. 5a plus 4b plus 3c is equal to -12. Line this one up underneath it. a plus 2b plus 3c is 6. Now notice here the c's have the same sign in front of them. To eliminate this time, I'd have to subtract. 5a subtract a, 4a. 4b subtract 2b plus 2b. -12 take away 6, -18. Now, just to show you that you can use elimination, I could continue with now take these two equations, line them up and eliminate, but just to show you that you could also use substitution as a part of the process, I'm going to switch plans now and finish the question using substitution. This would be the easiest equation to rearrange. I'm going to take the a to the other side and bring the 11 this way. So that's going to give me 6b. It's going to stay where it is. Take away 11 because we're going to move it over here instead. And I'm going to take the a over here. So now I've got a substitution for the variable a. A is equal to this expression. So I'm going to take this other equation and replace a with this expression, because it says here a is equal to this. So a could be replaced with what it's equal to, plus 2b. As we've noted already before, the beauty of this is now there's just a single unknown, the variable b. 24b, take away 44, plus 2b is -18. 26b. I'm going to bring this to the other side. So when I add 44 to negative 18, I'm going to get 26. Divide by 26, divide by 26. And there we have it. One of the variables. We've got the b. The next easiest undefined would probably be this one, because if I know b, I should be able to quickly find a. So let's switch now to a equals. So a is 6 times the b value, which is 1. Take away 11. So a is going to be 6 minus 11. A is negative 5. Now that I've got a and b, find the easiest equation you can. This looks like the easiest one, I would say. So it's a. Actually, no, I already know a, don't I? I just did a. So a is what number? So a is negative 5 and b is 1. So a is negative 5 plus 2 times b, which is positive 1. So a plus 2b plus 3c has to equal 6. So this leaves one unknown, just the c. We should now be able to solve for c. Negative 5 plus 2 is negative 3 plus 3c is 6. Move that over here to isolate your variable. 3c is 9. Divide both sides by 3. And c turns out to be 3. So my solution in alphabetical order would be negative 5 for the a, 1 for the b, and 3 for the c. And there you have it. Solving systems of linear equations that involve 3 unknowns and 3 equations. As hopefully you would agree, this is nothing more than taking what you already knew from grade 10 and just extending it ever so slightly to apply to a 3 by 3 scenario. And it's using the similar process, it's just it takes more work, that's all. Alright, so that is a look at how to solve linear systems of equations involving 3 variables from 3 different equations. So there are some practice questions for you to do in our class notebook. There is a formative that involves linear and quadratic, so you'll probably want to watch the next video before and do some practice on those as well before going to your formative, because it also involves systems that will use quadratic equations, and that will be our next instructional video. So best of luck with your practice questions, and then when you're done those, move on to the next video and familiarize yourself with how this process works when you're dealing with a quadratic. Thanks for watching. Any questions, reach out to me via Teams. Thank you.